Hey guys, we did this graph in the review session, and at the very last minute I changed the direction of this arrow so that you guys could see backwards arrow, and it turns out that that had cascading effects for the rest of the graph, so I wanted to start over and show you it all the way from start to finish. Okay, so just to keep in mind with Ford-Fulkerson, we have our source and our sink, S and T, and our residual graph in our original graph. And the goal is to find paths in our residual graph, and that will inform the amount of flow that we can put in any place down here. Okay, and there are smarter ways to do this, and there are more complicated ways to do this, but the fact is, as long as there is a path in this residual graph, you can pick any path that you want. And I'm going to show you how that works with backwards arrows. And so my forward arrows are going to be done in black, and my backwards arrows are going to be done in red to kind of show you this difference. So the first one that I'm going to choose is this 10, 1, 7. So the bottleneck is 1 here, and so I'm only going to be able to put 1, 1, 1 through here. Okay, and so I can draw my backwards arrows here. This is going to be 1, 1, and 1. And then I update my remaining capacities here to be 6. This one's going to be 0. I could erase this entirely, and in fact that's what I've done in my other examples. This arrow is going to come backwards and forwards a number of times, so I'm just going to leave it there so that I don't have to erase quite so much. And then this one is going to be 9 and 1. And remember that you can always check your work to make sure that these numbers add up to your original flow down here. So if this is 10, we've used 1, so we have 9 left. The black numbers represent the amount of capacity that we have left to go. Okay, so that's 1 that we can do, but see now I've got a backwards arrow, and I could do 10, 1, 6, 2. And what this backwards arrow means is that we have found an inefficiency in the graph. And so we're gonna reroute this to other places. And so I'm gonna take this one and I'm going to add, so whereas we subtract the black numbers to get our remaining flow, we are going to add them to our backwards arrows, which is our used flow. So as I do this, right, I'm gonna add my arrows here. And this one is going to become 10 and 1. Or sorry, 9 and 1, because I've used 1 up. But here, I go the other direction. And so this one becomes 0, and this arrow comes back and becomes 1. So really, I guess the simpler way to think about it is that you take whatever color number you have and you move it between black and red. So if this is 6 here, that becomes 5, and this one becomes 1 here, and this one becomes 1, and this one over here becomes 1. Okay, so let's see what else we can do here. So I see another path, which is going to be here, here, and here. So that is 9, 1, 6. And so I can increase my flow along there. So let me update my graph down here first. So I've got 1, I subtracted 1 from here, so this goes back to 0. And then this one is 1 and 1. So whatever these red numbers should be what is in your boxes in your flow graph. Okay, so I see another one. Let's take 1, 1, 1 there, and our bottleneck is this 1 here. So I'm only going to be able to move 1 flow. So this one becomes 2 and 8. This one becomes 0 and 1. And this one becomes 7 This one, this one becomes 5. And this one becomes 2. It's the wrong color. 2. All right, so 5 plus 2 is equal to 7, which is correct, and then I can increase my flow along this path. Remember that my flow is the same as the red numbers, so that's going to be 1, and this one's going to be 2. And one thing that I've figured out through drawing enough of these examples is that it works better if you say draw the black lines on top and then put the numbers on top, and the red lines on the bottom and the numbers on the bottom, and that'll let you keep this a little bit cleaner. Okay, so now we have a backwards arrow again here, and so we can do another path, which is 9, 1, 5, 1 here, and increase flow along there. Again, this one is a backwards arrow, so the flow, we are rerouting flow from this edge, but the way to think about it is that you take the number from one side and move it to the other, and for backwards arrows that you use, if you're using a red arrow, you have to take it from the red side and move it to the black side. Okay, so first things first, this one becomes 2 and 8. This one becomes 1 and 0. This one becomes 4 and 2. And this one becomes 2 and 0. Okay, then I can update my flow in my graph over here. You could do this all at the end, and that's fine too, because as I said, the red numbers are the same as your flow. So this will be 2 here, this one is 0, this one is 2, and this one is 2. Okay, and so once again, I have a backwards arrow here, but this one is officially gone. And I'm gonna go ahead and erase this so that I'm not constantly looking at it, wondering if I actually have a path there. I can always bring it back if I choose to. Okay, so let's see what else we can do. I see 12, 1, 4 across the top here. So let's go ahead and do that. And again, just to keep everything clean, I'm going to draw all of my red lines to the bottoms and write numbers below it, and all of my black lines will be on top with numbers on top of that. So this one's going to be 1, 1, 1, and this one's going to be 3, 0, and 11. I don't think this one is coming back, so I'm going to erase it again. Again, this is personal preference. You can leave it at 0, but I like to erase it. So now that I know that there's no way to get to this node at this time. Okay, and then if I update this here, this is 1, 1, and 1. Okay. I see yet another path here, which is 11 to 5. So my bottleneck is going to be 2. So I can add 2 to my flow on each place. Okay. And again, this one disappears since it goes to 0. And then, let's see, this one goes to my bottleneck was 2, so for this one goes from 1 to 3. I should have done this in order. 11 goes to 9. 9 plus 3 is 12, so that comes down here. This one goes to 0 and 2, and then this one I have increased by 2, so this one goes to 3, and this one goes to So then that becomes, down here, I can update based on my red numbers. So this is 4, this is 2, and this is 3. Okay, so I see yet another path here, which is this 8, 1, 3. My bottleneck is 1, so I'm going to add 1 to each side, so this becomes 7 and 3. This becomes 0 and 1, and this one becomes 2 and 5. So if you use a black arrow, you take it from the black arrow number. If you use a red arrow, you take it from the red number, and you give it to the other side. So that becomes 5 here, this becomes 1 here, and this becomes 3 there. Okay. So I'm looking again. This appears to be my only potential path in, because you can't get to that one. You can get to this. Oh, obviously we've got 8 and 2 straight across. Okay, so I can take this 2 here, and then this one goes to 0. And this one goes to 7. And then this one goes to 4 and 6. So that's 4, and that's 6. Okay, and then I update my flow here to be 7 and 4. Okay, and now at this point, I have no more paths to T, and so I've got 7 here, I've got 2 there. I could potentially do 3 more along this one, but there's no way to get to this node because this one is full up. And so I think I am finished, and I have found the maximum flow of this particular graph. So if I add up my numbers, I have 7, 2 and 1 is 10. And assuming that I've done this correctly, 4 plus 3 plus 3 is also 10. So the max flow, which is the same as the minimum cut here, is 10. And if I'm looking at it, I can see that that cut is right there. That's going to be the bottleneck. 7 plus 1 plus 2. Yeah. So, all right. And so hopefully this is helpful and you guys can really see Ford-Fulkerson and mid-cut max flow.